Hi there, you're welcome back to my channel. In this video, I'm going to take you through tangent planes. So this application of partial derivatives. So let's see, I have a problem here to explain this concept. Find the equation of the tangent plane to z is equal to natural log of 2x plus y at the point negative 1, 3. Tangent planes. This calculus formula, and if this is the first time you have been on this channel, kindly subscribe and also please watch this video to the end. So what do we mean by tangent planes? What do we mean by what? Tangent planes. So in our lessons in planes, right, to find the equations of a plane, you know that generally the equation of a plane is given as a multiplying x minus x naught plus b multiplying y minus y naught plus c multiplying z minus z naught, right, equals 0. Your A, your B, and your C are what we call the direction numbers. Okay, direction numbers. So it actually gives the direction of our plane. So before you find the equation of a plane, you need at least a point, okay, and a direction, which is the normal vector. Okay. So in this case, we want to find the tangent planes or a planes which is tangent to a particular function, right? So this is a function we have in space. So this z is equal to natural log of 2x plus y, right? So we want to find the tangent to this particular function here at the point negative 1, 3. You know that for a function like this, it keeps on changing, right? So with the particular value of x and y, z will attain a different value, right? So in order for us to find the tangent planes, equation of the tangent planes, we need a direction for our plane, because we already have a point here. We have a point here, okay? So we need, and with this point, we can put in to get our z component, right? We can put in to get our z component. So here, the next thing to do is to get our direction numbers. That is the most important thing. So how do we get our direction numbers, or what we call the normal vector? Normal vector. There is no way we can get a normal vector in this sense, but because it's tangent to this plane, I mean the plane is tangent to this function here, we can say that the change in this function with respect to x can give us the direction of our x, right? So we can say the fx of this function is the change in x. So fx of negative 1, 3 can give us the direction for x. Then fy of negative 1, 3 can give us also the direction for y. So in this case, we can easily find the direction numbers here. Can easily find the direction numbers here. Okay, so the only work to do when you are finding the equation of a tangent plane is to find your partial derivatives with respect to your function. And after you find the value of the partial derivatives at a particular point, and that will be your normal vector, which will give us our direction numbers. Then after, you use the point to find your equation. So let's see. Using this equation, what is fx, or what is the z on the x, right? So partial derivatives, we use this symbol, the z on the x. Okay, so the d is different from the normal derivative, okay? So you simply find the z on the x. So what are we getting the z on the x? If you have natural log function here, you know that you just take the derivative of what we have in the argument of the natural log all over itself. Is that not it? So what's the derivative of this? If you have z is equal to natural log of 2x plus y. So we want to differentiate this with respect to x. So y becomes a constant in this manner. So when I differentiate this with respect to x, I'm going to get 2 over the function itself, 2x plus y. So if I want to find the zx of zx at the point negative 1, 3, then I'm going to have 2 over 2 multiplying my x becomes negative 1, then my y becomes 3. So I'm going to get 2 over 3 minus 2, 3 minus 2, and that will give me 2, right? Then when I find my dz on dy, right? The z on dy, I'm going to get what? Differentiating with respect to y, I'll get 1 because 2x here is a constant, so to the 0. So 1 over 2x plus y itself. This should be equal to the zy at the point negative 1, 3 will give me 1 over what? 2 multiplying negative 1 plus 3. You know that 2 multiplying negative 1 plus 3 will give us what? 1, right? So therefore we get 1 here. So from here we can see that our normal vector, which happens to be what? The change in what? X and change in y component of our function, is given as 2 comma what? 1, right? So once you have our normal vector here, what do we need? We are only left with what? The point. And the point here is what? Negative 1, 3. In order to complete our equation, which is a plane, right? A plane is supposed to have what? X, y, and z component. Okay, so for this space, we are in the, once we make z the subject, we are in the xy plane. Okay, so we can use these 2 points to find the equation of the plane. These 2 points can give us the equation of what? The plane. Okay, so remember that we can bring z out. So from this equation, this is the general equation for what? A plane. To find a plane, right? And I said A, B, C are our direction numbers. But because the plane we are using here is z is equal to natural log of this, we will have to find what? The z at this point. Right now, we know that s is negative 1, then y is 3, right? But what is z? We simply write z will be equal to, we put natural log of 2 multiplying what? Negative 1 plus what? Our y. And our y is what? 3, okay? So let me do it here. Our y is 3. So plus 3. So this is the same as our z value is going to give us natural log of what? 2 times negative 1. That is what? Negative 2 plus 3 is 1. So natural log of 1 is what? 0, right? So the z value at the point negative 1, 3 is what? 0. So to write the general equation for our tangent plane, you write z minus z naught is equal to a multiplying x minus x naught plus b multiplying y minus y naught. Okay, so the reason why we have taken the direction numbers, the direction number of what z from is, we are in the z xy plane, right? So the direction for z wouldn't be considered. Okay, that is why we leave it like that. Okay, so we have z minus z naught. So right now we know that our z naught becomes what? 0. Z naught is simply the known value, that is the value of z at the point where we want to find the tangent. So we get z minus 0 will be equal to the a, which is the direction of x, was given by the partial derivative at the point, and it gave us 2. So 2 multiplying x minus, our x naught is negative 1, right? So x minus minus will be what? S plus 1. Plus our b is what? 1, which is a partial derivative at the point of y. So we get 1 multiplying y minus what? 1, right? So we simply, y minus 3, sorry, is positive 3 for the y. So from here, I get z is equal to 2x plus 2 plus y minus 3, right? So I simply get the tangent plane equation to be 2x plus y minus 1. So this is the equation of the tangent plane at negative 1, 3 to the function z is equal to the function z is equal to natural log of 2x plus y. Thank you for being with me in this video. Please don't forget to like, then also share.